Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to use the power of TI technology to explore and discover relationships. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. With us tonight is Roxy Runnels and Julie Riggins. Roxy is an instructional support teacher at Northside ISD in San Antonio, Texas. She's been a high school math educator for 13 years and a T-Cubed instructor for the last 4 years. She loves supporting teachers with technology and instruction to help math come alive for students. When she isn't being a math nerd, she loves to read and hike with her husband. Roxy, it's great to have you with us tonight.
I'm happy to be here.
And Julie was a math teacher in the Winston-Salem Forsyth County School System in North Carolina for 26 years before retiring in August of 2020. She enjoys being a stay-at-home mom for her 16-year-old daughter, Grayson, and going fishing on the Outer Banks with her father. She has also been a T-Cube instructor for a while, for 12 years, and loves teaching teachers how to use technology. Julie, it's great to have you with us tonight as well.
Thank you. It's great to be here. I hope we have something valuable for you to learn tonight.
So speaking of tonight, we are currently working on those welcome and introductions. We're going to take a look at a telescope activity with function notation, as well as quadratic attributes and equations with images. At this point, I'm going to ask Julie and Roxy to discuss the expected outcomes.
So in our first activity, we're going to use the TI-Nspire to analyze data with a movable line. We're also going to predict values using function notation. And we're also going to distinguish between independent and dependent variables.
And in our second activity, we're going to talk about graphing real-world applications using quadratic functions on the TI-84. We're going to build and check those equations using the calculator and verify student results.
Roxy, thanks so much. Tonight we'll be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link in the certificate of attendance at the conclusion of the webinar. At this point, Julie is going to take things over.
All
All right,
right.
Julie, it's all yours. Feel free to share your screen.
All right. So Roxy and I are going to begin our presentation tonight by sharing an activity that explores a linear relationship and introduces function notation. One of the first topics I teach in my Math 1 course is function notation. And anytime I'm starting something new, I always like to relate it to a real world situation. You know, I want it to be concrete so that my students can make a connection to the math, to something that they can understand and really get their hands on. So this activity they are going to collect some data. I love collecting data. And we're going to analyze data where they look through a paper towel tube. This is their telescope, right? And so the setup is you're going to have a group of 3 or 4 students, and one of the students is going to be the viewer, the one looking through the paper towel tube. You'll have another student that is measuring the distance between the end of the tube and the wall. And against the wall, there's like a yardstick or some type of measuring device. And then you'll also need a scribe to record the data. So if you have a group of 4 people, then one student could be standing against the wall kind of as a quality control person. And so the person looking through the telescope might say, I can see between, say, 10 inches and 21 inches. And so the student at the wall might say, that's 11 inches. And so the person writing it down can write down the distance from the wall and how much they can see. And the students will like go forward and backward and get different distances and different fields of view for each distance. For my students, I also demonstrate this one time. Like I get one group of students up at the front of the classroom and actually do this, you know, show them how to collect the data. All right, so let's see. So here is a group's data. And so, oh, and let me show you. So you will get a copy of the handout at the end of the session. And so this handout, and you'll see this one is for the TI-Nspire. And I said I was going to be demonstrating this with the TI-Nspire, but I do have a handout for the 84 as well. You could do the same activity with the 84. So this is the student handout, and they also get the diagram of the setup. And here's their data table. And they're going to collect distance and field of view data for 5 different distances. Notice there's more than 5 rows, but they're only going to collect 5 data points. Okay. So here is our first, this is the data that they collected, and the handout walks them through how to do this. But let me say this. This is the first time my students have used the Nspire as well. So I will send them off to collect their data, but then I will bring them all back together and we will do this part together. This is a lot of manipulation with the Nspire. And so the handout kind of walks them through it as well, but we do this as a whole class. So we are going to, first of all, add a page. We're going to add a data and statistics page to graph our data. And right here, I ask my students, okay, what does the Nspire asking, what is it asking you to do? And so they'll say, oh, it says click to add the variable. Well, right here on their handout, the next thing on their handout is where we discuss the idea of independent and dependent variables. And where does the independent variable go? Where does the dependent variable go? Which variable depends on the other? So we have this discussion. And then they can click and add their variables. So this person named their variables dis for distance and FOV for field of view. Now, all of the data values won't look quite so linear. If they're very careful in measuring, it will look linear. As you're monitoring the students when they're collecting data, you know, you can ask them, so what should happen if the distance increases? What should happen to the field of view? And they should say, well, it's going to increase as well. So, so if they have a data point that might be a little questionable, you might ask them to, how about maybe you can check that one again to make sure that they have pretty good data. Okay, so the next thing we are going to do is insert a movable line. So we're going to analyze our data with a movable line. So we're going to go to Menu and Analyze. And here's where you would choose regression if you wanted to do that. But we are going to do a movable line. And the Nspire will just put the line anywhere on there. And then the students will grab the ends of the line. See that? They'll grab the ends of the line like that. And try to get a pretty good fit. That didn't look too bad right there. So now I have a question for you. So our first question, so if you can answer in the chat, Roxy will kind of keep an eye on that and let us know what you think. So my first question to you is, if you had a distance of 0, what should your field of view be? Okay. So if you're looking through your telescope and your distance is 0, what should your field of view be? And if it helps to put the, there's the diagram, what people are going to be doing. So if the distance is 0, what should your field of view be?
So we have someone said the diameter of the tube.
Nice, nice. Very good. Okay. So if the distance is 0, so if I were to put a 0 in for x, so x is representing my distance, then I want the output or the field of view to be the diameter of this tube, which is about 1.5, maybe a little bit larger than 1.5 inches. So the students can grab the middle of the line and adjust it so that our y-intercept is, well, that's pretty good, about 1.5 or a little bit more. Might be a little too high if I do like this. So they can play around with it and try to get a good, that's not too bad, but try to get a good line that fits the data. Okay, so the next thing, I might ask my students this as well. So some of you know from middle school that your that number, that 1.5 or 1.6 is the y-intercept. Can we see the y-intercept on our graph the way we have it? So I'll leave that open to you too. Do we see the y-intercept? Or what would your students say?
Crystal says my students would likely say that they can see it.
Good, good. And some of mine do too. And so I would say, well, what is it? Because I think it's very important for the students to really, at the beginning of my freshman class, to start, analyzing this axis. What is this scale value? And so these are counting by twos. So if this is a 10, then this is like an 8. So we discovered that we can't see the y-intercept. So I want to show you on the Nspire, you can move your mouse and get a 2-headed arrow on the x-axis and drag it to the right. There's our y-axis. And then we have to move our scale up so that we can see the y-intercept. So, so that's nice for the students to get that idea of scale. And if you notice now the scale is counting by 5s. You see it. So, and that's tricky for the students. You guys know. Okay, so, all right. So now we have a movable line. I haven't asked you about the slope. So our slope is, you can see 0.368. I have asked my students to explain what the slope means with respect to the distance and the field of view. Oh, and I've also asked them to round to the 10th place. So our slope is about 0.4 or 4/10, and I may write 4/10 on the board. And I need to remember to mention that every group might have different data. So I'll come back to that in just a second after we talk about 4/10. So what do you think students would say, or what would you hope that they would say about slope with respect to the distance and the field of view if your slope was 4/10? And I'm sure you guys are getting ready to type something in, but you can see on my handout, I kind of help my students a little bit because they struggle with this idea of what does slope mean. That's what I love about using a real world example, because the numbers mean something, right? It's not just 0.4. What does it mean? So did anybody chime in, Roxy?
Stacy says 0.3 inches.
Okay, good. Okay. So as your distance increases by 1 inch, your field of view would increase by 0.3 inches or 0.4 inches. Good. And then I would want to extend that to as your distance increases 10 inches, especially if we wrote that fraction, 4/10, and really go ahead, like day one, start talking to them about change in y over change in x, right? So, so as the distance increases by 10, your field of view is going to increase by 4 inches. And I asked the kids, does that seem to make sense? If you backed up just a little bit, like 10 inches, is that going to show you, 4 inches? And they're like, yeah, yeah. So I saw somebody put something in there about different slopes. And something I didn't show you in the setup earlier, because I'm nervous and I forgot. So we've got a full-length telescope, the full-length paper towel tube, but I also have a paper towel tube cut in a third. So we have a little bitty short telescope and a middle-sized telescope, and then the longer telescope. And so each group gets a different size telescope. So I might have 2 groups that have the regular size. I might have 2 groups that have the little short size. And that's a nice extension to this activity. I'll show you quickly. So I have 2 more graphs from different groups open up. And so like Tyler's group here, notice his slope is 0.3. So Kaylee's, the one we were doing, was 0.4. Tyler's group was 0.3, and Ryan's group was 0.2. And that happened every time I did this experiment. So I know that Kaylee, with the largest slope, actually had the smallest telescope or the shortest telescope. And so I'm actually really excited about doing this, but I've never done it. So to hold the distance set and change the length of the tube. So stand at a particular distance. And I'm thinking about maybe taping 2 paper towel tubes together and then cutting it a third, a third, a third, a third. So we'd have 6 data points. I don't know. I'm like so excited about doing that now that I've been planning on this, but I don't know. I do know that that relationship is inverse, right? As the paper towel tube gets shorter, our slope, our field of view is going to get bigger. So anyway, so that's kind of an extension that you can have fun with. Okay, so back to the activity. All right, so the next thing I ask my students to do, once we get our movable line on there, we've talked about our y-intercept, we've talked about our slope, let's look at this data point. So this first data point is at 24 and 8.5. I ask my students now to use the line to estimate what the field of view would be. So, I'm looking at my line, and 8.5 is a pretty good estimation, but it looks like a little bit bigger. So maybe like 9.5 or 10. And remember the scale, analyzing the scale is very important. So maybe instead of 24 and 8.5, it would be in their third column, the field of view estimate from the axis using the fitted line. I might say 10. Okay. And then if I go to my next point, so this data point is at 3716. Well, my line is estimating closer to 15 probably, so 37 and 15. So they're going to 37 and 15. So they're going to enter in what the estimate is from the line for all 5 of their data points. Then we're going to get to do the fun stuff. We're going to use our function notation to evaluate what our field of view is. So to do that, we're going to do Control, Doc. We're going to add another page. And the page we're going to add is a calculator page. Okay, and watch this. This is pretty cool. I'm going to hit Variable. So what I ask my students, I'm going to ask you. My students know pretty much right off, okay, the DIS, the distance and field of view, is what I had on my other screen. what is M1? I want to make sure that every student knows what that M1 is and where it came from. So,
She says it's the equation of your movable line.
right. Okay, so back here on this page, this was the equation. That M1, that's the name, right? That's the function name. Okay, so we're going to go to variable, and we're going to arrow down and get that variable, that movable line function. And it's waiting for an input. So the first input that I'm going to use is that 24. And we'll see what it gives us. All right, so it gives us 10.4. So on their spreadsheet, they're going to put 10.4. And they're going to do that for all 5 of their data points. Okay, so they're going to do variable M1 and 37, I think was that other one. So that was 15.2. Okay, so there's 2, they're going to do that for all 5. Now there's 2 blank lines. So the next thing I would like for them to do is to choose a value, choose a distance where you didn't collect the data. So this group might choose 60 inches, or they might choose 100, they might choose 90 inches. So I might choose 90 inches right here. So there's 90 inches. And if I use my scale, looks like maybe about 90 and 35. 90 and 35. So I'll jot that down here. So 90 is my distance and 35 is my estimate using the axis. And then I'll also, on the calculator page, you can type M1. That's what I just did there. I just typed M1, but you do have to put the parentheses or it won't work. And then I can put 90. So 34.7. 4.7. So hopefully they're really seeing how this relationship, right? We want them to see that the multiple representations of this relationship and how the data and the field of view, the data and the line and the function notation all give you kind of a different view of this data or this situation. Okay, and the last line is, what if you go to 100 feet? Now I ask my students, oh, well, 100 feet, it's right here, right? And hopefully, one of the students will say, oh, wait, I thought that was 100 inches. And they're like, oh, right. So I asked my students, okay, so if I wanted 100 feet, where would I have to go? What would I have to do to predict 100 feet? And I don't know if anybody's want to type that in. I want to make sure I don't run over in my time. So, there we go. Robert Baker's got 1200, right? So instead of 100 inches, I need 1200 inches. So we're going to slide out like this. Oh my goodness, I got to go all the way to 1200. There we go. That's not very helpful without bringing down my field of view. So bring that down one more. There we go. So if I wanted to estimate this, it looks like about 1200 and maybe a little less than 450. And here's another good thing that students need to see. Now, notice my scale, we're counting by 50s now. So even though that looks like maybe, 449, it might actually be something more like 445. So our last row would be 1200, and we were thinking like maybe 445 or something like that. And I'm going to show you one last really cool thing with the spreadsheet, because if we use our spreadsheet, we can actually get it to plot that point on there and see that it's right on the line. So we're going to put 1200 into that cell, and it works just like a spreadsheet. So you could do equals M1. It knows that M1 is that function for this whole problem. So every time it sees M1, it knows what function to put in. And I could type 1200 here, but you can also type a 6 because that's the cell it's in the spreadsheet. 444. That's the closest I've ever been, and I've practiced this a lot. So that's 444. So right here we would put 444 there. So so the last thing, on the student handout, let's see, so all this is kind of, everything I did is in the student handout with some places for them to fill in some stuff. At the end of the handout, there's a little summary for the function notation. Notice I start off with M1 is the name of our function, and then our variables, but then move to more general. And I said our function was called M1, but many times we name functions with the letter F. So a typical function notation is f of x equals y, and bringing back in that idea of independent and dependent variable again. And I want to jump to, I think this is my 84. You can do this on the 84. You would enter in your data like you would normally, but when you do stat calc, you would scroll down to manual fit, and you can actually put a manual fit on the line. I'm sorry, you can put a manual fit line on the data, and you can change these values for slope and y-intercept. And then and the students can see the line change, which is kind of nice. And notice that the name for the function in the 84 is not M1 but Y1. So you might have seen that before. So with a little bit of wetting your whistle for the 84, I'm going to turn it over to Roxy and let her tell us about her activity. I think I did it right, on the 84.
All right.
Nice.
Pull everything up. There we go. So on the 84, we're going to graduate from linear functions to quadratic functions. And this activity is going to be shared with you guys at the end of our session this evening. And I'm going to run through this kind of as a student, the student side and the teacher side, because I want to demonstrate how students would get these images on the TI-84. Now, if you're using the Nspire, you can preload those images for students in the graphs page. So I'm going to zoom in here just a smidge. But if you have the 84, students are going to insert these images themselves, and we're going to run through this. Like I said, it's both a student, and then we're going to do some kind of behind the curtain teacher stuff too. So what I wanted was an activity where students were writing equations of quadratic functions, which, you know, is a pretty big chunk of, especially those Algebra 2 classes, some of those upper level classes, writing those equations given some of those attributes like your vertex, your zeros, your y-intercepts, things like that. But having students be able to check their work, I know especially if you were doing some virtual learning this past year, which I know a lot of us were, was so important for students to have that immediate feedback. And this is an excellent activity that allows students to do that. They can kind of check their work, maybe even do some guess and check, and we'll talk about that too, which has its own time and place, definitely, when students are starting to write those equations. All right, so what we're going to do is I'm actually going to build this on my calculator here so that you can see the image a little bigger, because this image is quite small. And so, oh, nope, there we go. So the first thing I'm going to do is I'm going to load this image in my calculator, and it's got the directions here for your students each time they see that problem, because I mean, that's not a math skill, loading an image. So I like to give my students those directions every time. So I'm going to hit second and format. And I'm going to do two things on this screen. The first thing is I'm going to come down to the background, and the background is turned off right now. And I'm going to come down, arrow all the way down. I'm going to turn this image on so that it matches the image on my handout. It's the bridge. Oh, lucky me, it was the first one. That was luck. I just really liked this bridge. Now, the second thing I want to do is, as a student, because these screens can be quite small, so I want to turn my grid lines on because it might help me find some of those attributes a little easier. So I'm going to come up to this third line, and your grid is defaulted to off. And I know some students prefer that dot grid. Me as a student, I prefer that line grid. I'm going to turn the line grid on, and we're going to see what that looks like. So I'm going to go to graph, and that's what my graph now looks like. So if you look at it here, if I zoom in, this is what it looked like without the grid. I went ahead and included that grid because I want to find some of those attributes. So the first thing we have here is, what is the vertex of the parabola? So I want to know, what is the vertex, the top point of the parabola on this graph? And I do explain a little bit here in the word problem that the arc and the bridge in this image is parabolic. And so we're going to assume that it is a parabola. So if y'all would please take a look at that and tell me, where do you think that vertex is? And I'm going to zoom it in just a little bit so y'all can see a little better on your screen. Now I want you guys to answer as a student, where is that vertex? Wrong answers are also welcome.
So we have one, it says, I think it's -1 and 1.3.
Oh, that's a really good one. I like that one a lot. -1 and about 1.3. That's a really good point. Very nice. We'll go with that one. I'm going to make a note because I like that one better than the one I had. -1 and 1.3. I'm just going to write it down because we're going to use that in our answer here in a minute. Then I ask a few questions of my students. And of course, I'm going to share this with you at the end. It's editable. Feel free to make changes so that it is better usable to you and your students. A little bit, there we go. I like to ask my students, what direction does this parabola face? Because that's going to kind of lead them into thinking about that A value. Is your A value positive? Is it negative? And then we're going to talk about, when we compare that to this parent function, f of x is equal to x squared, is it vertically stretched or vertically compressed? So I want to ask you guys, as a teacher, what would you think students could do to check if they can't remember that vocabulary? Because I know that students often get that vertically stretched and compressed confused with the horizontally stretched and compressed. It's a little different, and they have trouble with that vertical horizontal, right? So what could students do to check that? Because you know that they may not go look in their notes, but how could they use their calculator to help them kind of make and test a conjecture to see if they're right? What do you think they could do? All right. So what I'm going to do first is I'm going to go ahead and I'm going to graph this parent function, but I'm going to graph it so that it is transformed. So graph the parent function and play. Oh, yes.
There you go.
Type in different equations and graphs. Exactly. I was trying to lead y'all to it. Please, you guys, help me out. Participate. I need it. So you want students to kind of play with those equations. I want them to put in some wrong answers to see what could it do? What lead them towards that correct answer, right? So if I'm using this activity and I'm asking about the vertex, I'm probably wanting them to write this in vertex form. That's what I'm leading them towards. And if you see that later down here, that's what I asked them to do, is to write it in vertex form. So I'm going to write this equation. And we said, well, it's facing down. So I know I'm going to have a negative A value. I'm going to go ahead and write this in vertex form. X, which is up here next to that alpha, we said 1 and 1.3, so it's going to be plus 1 squared and then plus 1.3. And let's graph this and see. So if this is that parent function, and I've just done some transformations, we just shifted it over so that our vertices, our vertex of our bridge parabola and the vertex of our transform parabola match up, and that is a beautiful match. I love that 1.3. But this is where you can maybe stop and have some discussions with your students if they're struggling to see, okay, is that going to be a vertical stretch or a vertical compression? What's going to need to happen to this blue graph so that it matches our bridge? And you can have those discussions. What needs to get wider, and to get wider, we have to vertically compress, right? And you can talk about, well, what types of A values would you need to get that compression? And of course, we would always talk about in my Algebra 2 classes, you need those fat fractions, right? To get a wider fraction, to get a wider parabola, you want an A value between 0 and 1. Yes, and wrong answers are amazing. And that's what I love about activities like this, is it allows students to have those wrong answers and then kind of test themselves. Well, what do I need to do to make it a right answer? So then I want students, of course, to write the equation of the parabola in vertex form. And then I want them to reflect. I want them to reflect on their wrong answers. I always celebrated wrong answers. If you've ever done like my favorite no as a warm-up, that was always one of my favorite activities. But it helps students to process, and they remember their mistakes more than they remember their successes. And if they can analyze their mistakes, they're going to remember the math, which is what I want. I kind of set this up so that they do make mistakes. And for this particular problem, it would depend on where you are in your standards, what type of math class you're in, and I kind of left this first problem open so that students, you have different ways to get there. I might want them to guess and check that A value. Maybe we're exploring what that vertically stretched and compressed means. Or maybe you want them to pick another point, possibly one of these zeros, or your y-intercept, and actually solve for that A value. I believe I'm going to come in and insert. I love this pretty math type for our fractions. I used 1/12, and let's see if 1/12 still works really nicely with that 1.3. So now I'm going to graph and see. Oh, and look at that beautiful parabola. It is one with our bridge. And now students can check and see immediately if they got that right. They don't have to wait for you to come around and check, or turn it in and get it back a few days later and they've already forgotten about the bridge problem, of course. And they get that immediate feedback for themselves, which is amazing. And the really neat thing about this is I actually had a different answer. I said 1.5 as my y value for that vertex, and 1.3 and 1.5 both work beautifully. So your students can all have slightly different answers, and you can still be correct. And you can talk about those real world applications where on the real world you have that little bit of wiggle room. You know, gravity's not always perfect, or you have wind resistance, or someone might have been off just a little bit, and I'm short, so I see it a little differently. And things like that. So you can see that you have multiple correct answers because the world we live in is imperfect. All right, so the next problem, I'm not going to do all of these problems. There are a couple on here. The next problem, let's see, I can grab this. Sorry, y'all can see my Harry Potter there in the background. And the next problem here is this lovely water fountain. And this is another one of the TI images that came on my 84. And it was another very lovely parabola. So I used this one, and I asked a few more questions on this one just as an example. I wanted to show you can ask about different attributes. So this would be an example of perhaps where I want students to use those points to write that equation. And again, this will be shared with you, and it is editable. And I asked them to write the parabola in factored form this time. But then down here, I have some problems, some images that are not from TI. So this guy here is a ski jumper. And I actually did a Google image search, and I'm going to show you. It was the very first search. I came to Google and I said ski jump parabola. There we go, parabola ski jump. And then when I went to images, that was the very first image that I found, and I saved that image and uploaded it. I'm going to share with you guys how to do that also for the TI-84. and that image worked out very nicely. And I liked this image a lot. I actually had chosen another image at first, but I really wanted to have an A value that wasn't a fraction between 0 and 1. And this one actually came out to be a very nice A value of a -2. And then the last one, Julie and I had lots of really great discussions on this last one, because we were trying to think of different real world applications. And I thought, skateboarding has been just popular with kiddos since what, the 60s. It's popular, it's still around, kids are still doing it. So this image, I did not do a Google search. I went to a skate park down the street from my house and actually took this picture. And I, for the life of me, could not remember what this particular rail type was called. So I did what, well, anyone with a Facebook page nowadays could do. And I shared this image on my Facebook and asked my friends, what exactly is this called? Because I wanted to use the terminology that students would see, recognize, and understand, because I wanted it to be relatable to them. And the answer I got was, this is a rainbow rail, is what this is called, just in case you were wondering. It's actually called a rainbow rail. And there were some very nice young men that were out there skating and let me take some pictures. And that's something I want to do with you guys. I want to kind of crowdsource this, because Julie and I had some ideas and we're like, let's do a positive A value. And I realized it's really hard to do a positive A value for a quadratic in a real world application, because so many things we deal with gravity, which is what goes up is going to come down. So I want to ask you guys to kind of think for a moment and share in the chat. Can you think of anything that we could find a picture of or take a picture of to show to students as a real world example where your A value would be positive, so that our parabola would be facing up? Ooh, that's a good one. A rope bridge. Oh, a satellite dish. If we could get a cross section of a satellite dish, that's a really good one.
And a dry pond.
Oh, a dry pond, yes. I'm gonna have to scroll up some. Though the rope bridge, I am gonna say you can get it. It's approximately parabolic, but I think it's called a capillary. It's a better fit if you get into calculus. I think I remember that being a capillary when I took physics a very long time ago. But it would be approximately parabolic, exactly.
The headlight of a car, David says.
Oh, that's a good one too. Yep. Definitely. And some of these you may not be able to take an image, like a picture yourself. You may need to get a cross-section picture, right? And that's catenary. Thank you. I called it a capillary.
I knew somebody would know the answer though. So that's what this is for, right?
Exactly. We're gonna crowdsource it. Ooh, a contact lens laying down. Very nice. Ooh, and you could take a picture of that yourself too. Yeah, I'm thinking like I'm gonna need a dark background and my ring light. Sorry, I'm wanting to take some pictures of some more of these. Very nice. All right. Thank you guys for doing some crowdsourcing there with me, because those are hard to think of and find. Ooh, a spoon. Now y'all are just like really giving me some good answers. I've got to stop because now I'm gonna get distracted. I want to go find all these pictures. So I do want to show you guys how, once you've either found a Google search image that you really like, that works well for you, or you've taken a picture, how to upload that to your calculator. All right, so what I did was, and this might be a little loud because I'm going to turn my calculator on and I'm going to plug my TI-84 here in to my computer so that there we go, so that it recognizes it. And I'm just going to use the TI Connect software, and to transfer an image over to your calculator, you're going to go to the screen capture. I'm going to go to the open folder button here. And then I saved mine on my desktop. If you save it somewhere that's easy for you, where you know I save lots of images. Sorry, let me come down here to, I'll go to my skate 2. I call it skate 2 because I took a lot of skate pictures. And then you're just going to click here on the send picture button. And it's going to think about it for a second. And you're just going to tell it where to go. So I believe it's the first 7 images are already saved. You can override those with one of your images if you wanted to, or rearrange so that maybe they're in a certain order for students. But that's why I would want to give them this handout. That way they can match those images, of course. I want you to say image 9, okay. And it's going to copy it over. But while it's thinking about it, I'm going to see if I can come in and show you guys. My screen may be a little blurry. No, you're not going to be able to see my screen. It's too bright. But it's shared it right over to my calculator. It's still sending here, but I sent it earlier, so that it's hoping to show y'all. But it's hard to have those handheld devices with the camera right there in front of you. But you can just send those right over to your calculator. And of course, if you've got the Navigator system with the Nspires, it's super easy. And with the 84s, you can do your daisy chains or your chains and kind of, I used to call it infecting. My kids would need to share, and I would tell them what files they were sharing. Close that out for now.
And Roxy, that TI Connect, where do you get that?
That is on the TI website. So you can do a Google search or go to education.ti.com, and it's one of those software downloads.
Okay.
Very good. I see a question. Can you connect a thumb drive with images to a calculator? That's a good question, Robert. So not directly. What I would do is if you've got some images on a thumb drive, I would save them to a folder or a specific place on your computer and then upload them that way using that TI Connect. Good question. All right, and I do want to let you know, because I want to show you this picture. I'm going to turn the grid off and come down and insert my ski jumpers. See, lots of beautiful pictures. There's my ski jumpers. I'm going to grab, well, let's go to y equals. I'm going to turn this one off. Go to my graph. And it's a beautiful image. It really came up nicely. I'm going to make it a little bigger so we can see it. It really came up nicely. You can see your ski jumpers, but you got a lot of white space. And if you don't want the white space, I'm going to let you know you want to make your image 320 by 240 pixels. That's going to be a really good size match. I did this one not that size intentionally because I wanted to show that even if you don't get that exact size, it's still going to work for you. And this one happened to work really nicely with a really nice vertex. The vertex, I think, was 0.5 and 8 worked really nicely. And then my zeros were really nice fractions. They were, what is that, -1/2 and then 2.5. They worked out really nicely. I got lucky. But you can kind of move things around. And that's one of the reasons at the top, I would always ask my students when we started a new problem to clear their memory, clear their memory, clear their memory, reset their calculator, because if they moved that window at all, kind of reset them back to the beginning. And that was an easy way to do it rather than doing it manually. All right, are there any questions in the chat? I kind of let the chat get away from me.
Michael put up that you could, you know, the Education TI website that you mentioned. And I did notice another question, which I thought was pertinent because, you know, can all 84s add this image? And I also mentioned in mine about the manual line. And so I didn't know if you wanted to say something. I don't know what particular version it is.
Oh, that's a very good question. So I'm using the TI-84 Plus C Silver Edition. And this is actually, I'm going to unplug it so it might beep. And there we go. And it is, you can see it's quite a she's a big girl. This is it's one of the first color graphers for the 84, and it works beautifully on here. I know it works beautifully on the CE, which is the emulator software that I'm using, which is the newer software than this one. I was really excited when this came out. My husband actually pre-ordered this for me way back when. It didn't come in pink. He made it pink for me.
Woo.
Lucky gal. But that's a good question. I don't think you can insert the images on the 84 on your black and white graphers. If anyone has done that and can correct me, please do, but I've never seen an image being inserted on the older black and white graphers, the TI-84 Plus or the TI-84, or if you still have one, a TI-83.
And you should update your operating system, and for your students too. You can update your operating system, their operating systems, to do that the fractions like you were saying. Yeah.
It makes those fractions really nice for students. I know that I worked with some kiddos this summer, and with the pandemic and virtual learning, we were going back and forth between the Nspire calculators that they were used to having in the classroom to the 84s, because we were able to get those on their Chromebooks, and we have some testing software that has the 84 embedded, and it was the 84 plus CE, so it had the color grapher, and that fraction with the updated software was very powerful for some of those kids because they'd never seen the fraction the other way. It was just, it really threw some of them for a loop, and it was nice to be able to update their OS on those calculators for them so they could see those nice graphs. Yeah. So if y'all haven't seen the chat, Mike did let us know you can't upload those images for anything older than the C. And it's that resolution, and that's kind of what I thought, that resolution for your old school black and white calculators just isn't there, but it's beautiful for the CE. And it's really nice, and kids get really excited. And if you can get kiddos to take pictures themselves, because your kids love taking pictures, right? If you don't know, ask them about it. They love taking pictures, and you can have them share those pictures with you too, and then send those out to their calculators. And I'm sure they'd be so excited to see their picture on everyone's calculator. You could be the new Twitter with your calculators.
Hey, Roxy, any chance you could do me a favor? Can you go through the steps to upload a picture one more time?
Yes.
Again, this is for anyone that would be using the TI Smart View software.
Yes. So if I'm using the Smart View software, what you're going to do is I actually saved my images to my desktop just because I like to drag and drop. Oh, let go. There we go. Right down here, I'll let it load. It's gonna be your Emulator Explorer workspace, and you've got all of your images here. Let me see. You can upload an image. I like to drag and drop personally. That's my favorite. Oh, come on. And I'm just gonna drag. I'll drag my skate picture. When I drag and drop it, it's gonna ask me where I want that image to go. And so you can override with that 1 through 7. I usually like to leave those alone and kind of move it towards the end. If I move it to, let's say, image 8, and you can say replace the existing content and send. It's going to think about it. And now once you go back to your calculator, bring this back up so y'all can see my buttons. Format. When I go down to my grapher, I did have that image in 8, and now it is also in 7. You can see that I'd made a few adjustments. That was my original image before I made any edits to it. So now you can see that's right there in your emulator software. And that's how you would insert it if you're doing the emulator there for your class to view those. Good question. Thank you for that, Mike. Do we have any other questions? I don't see anything else in the chat. Oh, someone asked the best size. Yes, and I said this a little earlier, but I'll say it again. I did a little research and I found that 320 by 240 is a really nice size for your calculator. That's a really good question. The best image size. The tutorials, there's a question about tutorials for this. So this video is going to be made available to you guys after this evening. It's usually later, a few days later. And a lot of this information, when I was doing some research before and then, you know, a little closer to our to this evening, I did some Google searches, and there's some very long videos out there of people demonstrating some of these things, but they are out there. Good questions. That's about all I've got, so I'm going to hand this back over to you, Mike.
Perfect timing.
There we go.
Thank you so much. So I know we just got a question about tutorials, and this is something that we haven't talked about in a while, so I appreciate the question. Let me share my screen. And so on our website, education.ti.com, let me show two things real quick. One is the link I posted earlier. If you go to downloads, you can either go over here to 90-day trial or over to products, and computer software is another place. And you're looking for the TI-Smartview emulator for math print calc. No, there we go. TI-Smartview CE emulator software for the TI-84 plus graphing family. So if you were to click on that, it would give you some options about if you want to buy it or you want to request a free trial. Also, if you happen to have it and yours maybe isn't updated yet, you can also update it here as well for free. As far as tutorials go, under the Resources tab, slide down to Tutorials, and we have a bunch of really great videos for the Nspire. And then if you click on Graphing Tutorials, there's some tucked in there for the 83 as well as the 84. So let's say you click on the 84 just to kind of show you what's available. So you can check out, these are really nice because they're so short and you can just kind of scroll through and be like, oh yeah, that's right, that's what I need to do. There's a lot. So feel free to check these out. Again, they're all free and available on our website. All right, as promised, we are giving out a link here to the documents that were used tonight, as well as a link for the certificate from tonight. So if you happen to miss those links for any reason or they're not working, just hang tight. You're automatically going to get a follow-up email in a couple days, and that follow-up email contains not only links to the certificate and the documents, but also links to the recording as well. So it's kind of helpful to have all of that in one place. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you have any questions after the webinar, feel free to give us a call at 1-800-TI-CARES or drop us an email at ti-cares@ti.com. Lastly, when you leave the webinar, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online events, so please share your thoughts in that post-webinar survey. So huge thanks to Roxy and Julie for everything you shared tonight. Thanks so much for putting everything together.
Thank you.
We had so much fun.
And thanks so much to everyone for joining us. Stay safe and have a great night.